Welcome to this third part of digital electronics solved problems. In the first part, we have discussed on number system. The second part, we have discussed on complement. In this, we will discuss on the Boolean algebra and how to form the truth table. So let us see the Boolean algebra, the fundamental laws. So the identity law says that any number a plus 0 will give you a. And if you give a dot 1, it will give you a. The null or dominance law says that if you add 1 to a, it will give you 1, and if you multiply that with 0, it will give you 0. The idempotent law says that a plus a will indicate a, and a dot a will give you a. The complement laws of a plus a bar, which is the NOT operation, will get 1, a dot a bar will get 0, a double bar, so we are doing the NOT 2 times, we are getting a. The commutative law, a plus b will be equal to b plus a, and a dot b will be equal to b plus a. Some more laws we have, such as the associative law, distributive law, and absorption law. In associative law, we can say that we are basically associating the variables. For example, here if you have 3 variables and 2 variables are grouped together, b plus c, we can also group a plus b and take out the c from the bracket. Similarly, if we have multiplication of 3 variables, we can group b and c together, or we can group a and b together. Similarly, the distributive law, we are distributing the variables which are there in the bracket. So we have a into b plus c, which gives a b plus ac. Similarly, here we can write a plus bc as a plus b multiplication with a plus c. The absorption law, which is a plus ab will be equal to a into a plus b will be equal to a plus a bar b will be equal to a plus b, and a into a bar plus b will be equal to ab. These laws are important in Boolean algebra because we will see how these laws are basically used to simplify our expression. What is De Morgan's theorem? So De Morgan's has given 2 theorems. One is the first theorem and the other one is the second theorem. So first theorem says that the complement of a sum equal the product of the complements. So we have the sum a plus b, and then we are taking the complement. So that gives the product of its own complements. So a bar into b bar. Similarly, in the second theorem, the complement of a product equals the sum of the complement. So first we have the product, so a dot b, and then we are taking the complement. So we are getting a complement plus b complement. In its extended form, we can have multiple variables. So here we can see we have 3 variables, a plus b plus c, that is a sum, and then we are doing the complement. So we will be getting the product of its own complement, a, b, and c complement. Similarly, if you have the product a, b, c, and then we are doing the complement, we will have a complement plus b complement plus c complement. What is the key point? You can break the bar and change the operation from and to or. Problem number 26. In this third tutorial, we'll first form the truth table and learn how to construct the truth table. So let us take an expression which is f equal to ab plus a complement into c. So here we can see that this is basically a function which is having 3 variables, a, b, and c. So first what we need to do is basically creating 3 variables, a, b, c, and all the possibilities of the digits that we have, binary digits. So it is 0 and 1 forming. So we will first put that in the tabular format. So these are the basically all the possibilities that we can have for a, b, and c. Now our first expression that we have is basically product of a, b. So we will be obtaining what is the product of a into b. So 0 multiplied with 0 will get 0. 0 into 0 will get 0, 0 into 1 we will get 0, 0 into 1 will get 0, here 0, 0, 1 and 1. So this product of AB we are going to obtain. In the next, we will going to obtain the A complement C in the similar fashion. So first we need to do the complement of A this can be added in the truth table, or it can be done in a mindful way. So 0 will become 1, 0 will become 1, 1, 1. This is 0, 0, 0 and 0. So then we are going to multiply this complement with C and we try to obtain these values. Finally, we are going to add these two expressions and we will be getting the value. So 0 plus 0 will give 0, 0 plus 1 will get 1, and so on and so forth. So this is basically the function whose output 1 for row 1, 3, 6 and 7. Now this we will learn in the fourth part of the tutorial, how to form the mean term notation, because we have a 3 variable a, b and c. So in the mean term notations, how we can write 1, 3, 6, 7 and the summation, this we are going to see in the fourth part. Okay. So now for now we will form the truth table. Now we are going to see the Boolean simplification using laws, which is involving 3 variable a, b, c, and we have 3 expressions that we need to do the simplification process. So here we have, this is the basic function. First we are going to do the factor of a, b bar. So we can take a, b bar as the factor. So we'll get c plus c bar from the first term, and then we will add a, b, c. Then we can take the complement law, and then once the complement is basically taken, so you can see c plus c bar will become 1 here, and then we will get this value. Then make the factor of a. So this is the factor of a we are going to, and then we will apply the absorption law, that is b bar plus bc is equal to b bar plus c. And finally we will get the simplified format of this particular expression, which is f is equal to a into b bar plus c, and this is the simplified format, and still we can take these terms out, so we can have a, b bar plus ac. So what we obtain here, that there is a gate reduction. So originally there will be requiring 7 gates, but this will be simplified, required only 4 gates. So when you do the simplification of these expressions, the number of gates will be reduced. Now we will see the consensus theorem and how to do the simplification. So this expression we are going to take and apply the consensus theorem. So before that, let us understand what is consensus theorem. So here you have 3 variables x, y and z, and if these variables are present in this fashion, xy plus x bar z plus yz, then that gives us xy plus x bar z. So here what happened is that if you see this function and this consensus theorem, we find that the term bc in the consensus term can be eliminated by properly applying it. So the functions ab plus ab bar c plus bc, when we apply the consensus theorem, then we can eliminate the bc from this expression and we will get ab plus ab bar c. So this can be verified by expansion process also, like what we have the BC. So BC is equal to BC into 1. So A1 can be written as A plus A bar. So this is equal to 1. And then we expand it and then we find out. So ultimately we get the same answer that we have. So consensus theorem is useful in many cases to do the simplification process. Now we try to learn the De Morgan's theorem application. So this is problem number 29, where we apply the De Morgan's theorem to this function, what we have a plus b into c plus d, and then we have the complement. So first apply the De Morgan's first law and break out the bar. So here what we do is that since we have a product here, we convert that to sum, and then we get a plus b complement plus c plus d complement. So this is in accordance with the first law of De Morgan. Now you apply the De Morgan's to each term now. So here you have the sum, so it will convert to the product. So you have a complement into b complement. Here you have c plus d complement, so that will give c complement into d complement. And finally your answer will be a complement into b complement plus c complement into d complement. So if you want to verify this, you can construct the truth table for both the expression, and you can see that both will give you the same answer. Now, if you have a more complex simplification process where you have the expressions like this with the 3 variables, and the function is a bar bc plus a b bar c plus a b c bar and then a b c. So what we do is that we take this expression and we rearrange the term properly. So first we rearrange it in the proper way so that we can do proper factorization. Now if we arrange the first expression in this format, just changing the placement, and then we do the factorization properly. So here we have a bar a, which is equal to 1, and that will give me a bc here, and then we apply the complement law. So once we apply the complement law, and the next step when we factorize it, we can note that a b c bar will be equal to ac bar b. So we put it here in the next expression, and here again we are finding that b bar plus b is there, which is again equal to 1. So final form we are getting as bc plus ac. So alternative approach, if we apply, rather than going by this way, we can easily take out the factor and take the grouping, but we will be getting this expression of the f. So this complete this part of the tutorial where we have discussed very briefly on the Boolean process, algebra, De Morgan's theorem, and how do we apply that in truth table and the simplification process. In the next tutorial, we are going to see the standard form like sum of products and product of sum, and how to apply in the mean term and max term simplification process. Thank you for now.